Right now, as you're watching this, there is something in space so powerful that if you got close enough, it would stretch your body into a strand of spaghetti 1,000 miles long. And here's the part that should really keep you up at night. According to one of the most respected physicists alive, everything you are, every memory, every thought, every atom, might already be written on the surface of one. We've all had that moment, right? You're staring up at the night sky. It's vast. It's dark, full of tiny specks of light. And you get that weird pull in your chest, that question you can't shake. What's actually out there? Well, stick with me for the next few minutes, because the answer is stranger than any sci-fi movie you've ever seen. And by the end of this video, I'm going to show you why falling into a black hole might not be the end of you at all. It might be the beginning of something so bizarre, scientists are still fighting about it. Black holes. You've heard the phrase cosmic vacuum cleaner. You've seen the swirly CGI in movies. But here's what nobody tells you. That picture is almost completely wrong. A black hole isn't really a hole. And things that fall in, they don't exactly disappear. The real science is so much weirder. We're talking about gravity so extreme that not even light, the fastest thing that exists, can escape it. Kerr, 1963. The edge of this zone has a name. It's called the event horizon. Penrose, 1969. Think of it like the lip of a waterfall. Once you tip over, no amount of paddling saves you. You're going down. But here's the question that has tortured physicists for 50 years. What happens past the edge? Does everything that falls and just cease to exist? Because if it does, and I'm not exaggerating here, it would mean one of the most important laws in physics is broken. They call it the information paradox. And the answer to it might rewrite what we know about reality. So don't go anywhere. This gets wild. Okay, buckle up. Let's imagine you do the unthinkable. You're in a spaceship. You're heading straight for a black hole. And not a baby one. A supermassive one. The kind with a mass millions or even billions of times our sun. Cormindy, 2004. The one sitting at the center of our own galaxy. 4 million suns squeezed into 1 point. Gez, 2008. Let that sink in for a second. Now here's where things start to break. As you get closer, time itself starts acting strange. Einstein called it time dilation. The stronger the gravity, the slower time moves for you compared to everyone else. So picture your friend back on Earth. They're watching you on a screen, waving goodbye. As you approach that event horizon, watch closely, your clock ticks slower, and slower, and slower, until, from their view, you freeze. Right at the edge. Forever. You never cross. But from your perspective, you don't feel a thing. You just keep falling. And then it starts. The gravity pulling on your feet is now stronger than the gravity pulling on your head. Way stronger. So your body stretches. And stretches. And stretches. Scientists literally named this spaghettification. I'm not joking. That's the official term. You become a strand of human noodle, pulled into the abyss. Meanwhile, your friend still sees you frozen at the edge. They're waving. You're gone. Both are true at the same time. And here's the wildest part. This isn't theory. Time slowing near massive objects has been proven. GPS satellites in your phone have to correct for it every second, or the maps would be useless. Haffel, 1972. So yeah, spaghettification is bad. But it's not the real mystery. The real mystery is what happens to all that stuff that just got stretched into oblivion. Because that's where physics starts to scream. Here's a word that's about to become very important. Information. And no, I don't mean Wikipedia facts. In physics, information is the unique blueprint of everything that exists. Every atom in your body has a specific state, a fingerprint. Nothing else in the universe has the exact same one. Here's the rule. Information can never truly be destroyed. Ever. Burn a book to ash, and yeah, the book is gone. But if you could track every molecule of smoke, every photon of heat, every speck of carbon, in theory you could reconstruct the book. Scrambled? Sure. Gone. No. This is one of the most sacred laws in all of physics. And black holes seem to shatter it like a baseball through a window. Because when something crosses the event horizon from the outside, its information appears to just, poof, vanish. Then Stephen Hawking made it worse. Way worse. He discovered that black holes aren't actually black. They slowly leak energy over unimaginable timescales. We call it Hawking radiation. And when a black hole has leaked long enough, it disappears completely. Here's the part that broke physics. The radiation coming out looks totally random. It doesn't carry any information about what fell in. Hawking, 1976. So picture it. A black hole swallows a library, a star, your grandmother's wedding ring. Then it evaporates. And all that's left is random static. The fingerprints are gone. From the universe. Forever. That's the information paradox. And it's not a small problem. It's the kind of problem that suggests the foundation of physics has a crack in it. If information can really be destroyed, then pretty much everything we think we know about how reality works is wrong. For decades, the smartest people alive stared at this and had no idea what to do. It was like building a skyscraper on quicksand. But then, and this is the part I've been waiting to tell you, someone had an idea so strange it might actually be true. Stay with me, because this is the part that melts your brain. Two physicists, one Mel DeSena and Leonard Susskind, dropped a theory so wild it sounds made up. They called it the holographic principle. Mel DeSena, 1997. Here's the core idea, stripped down. What if the information never actually goes inside the black hole at all? What if it gets stuck on the surface? Like a hologram. You know those shiny 3D images on a credit card? They look like they have depth, but they're painted on a flat layer. Mel DeSena and Susskind are saying the event horizon might work the same way. Everything that falls and gets imprinted on the surface, like a cosmic security camera recording every single atom, every single fingerprint, onto the boundary itself. And then, and this is the kicker, when Hawking radiation slowly leaks out over trillions of years, it carries that information with it, scrambled beyond recognition, spread across the universe, but not destroyed, still there. Think about what this actually means. It means if you fell into a black hole, you wouldn't vanish. You'd get encoded, painted onto the skin of the universe's strangest object, slowly broadcast back out into space, particle by particle, over a time so long it dwarfs the current age of the universe. Not a death sentence, a transformation. The universe might be keeping track of everything. Every lost book, every fallen star, every person, all of it, written somewhere, just waiting to be read. And the evidence keeps rolling in. We've detected black holes slamming into each other through gravitational waves. Abbott, 2016. We know there are billions of them in just our galaxy. McKinnon, 2018. They're everywhere. And if this theory is right, they're not destroyers. They're archivists. So here's your takeaway. Next time you tilt your head back on a clear night and see those specks of light, remember this. The scariest looking objects in the universe might actually be the ones holding onto its memory the tightest. Black holes aren't drains. They might be libraries. Keep asking questions like this. Keep pulling on threads. Because what sounds impossible today is exactly what someone is quietly proving tomorrow. The universe is playing a very long game, and it's keeping the receipts. But now I have to leave you with a question that's been bothering me ever since I started digging into this. If information is never destroyed, not by fire, not by time, not even by a black hole, then what does that mean for the information of you? Every thought in your head, every memory you've ever had. Where does all of that go? I've got a theory, and it's genuinely unsettling. But that's for the next video. Drop your guess in the comments. I read them. And if your brain is buzzing right now, hit that subscribe button so you're there when we go even deeper. There are a lot more questions where this came from. And trust me, the universe isn't done surprising us yet.